Hello everyone, welcome to the 7th video of the unit real number. This video is about radical notation. So in this particular video we are going to see different types of notation to represent the nth root of a real number, nth root of a number. Okay, so the different types of notations are radical notation, fractional index notation, power notation. Okay, so these are the three different types of notation to represent the nth root of a number, and we are going to see some problems. Okay, first we'll see what is radical notation. Right, for that we'll take a positive integer n and a real number r. Okay, so we are going to multiply this real number r with the same real number n times, that is r into r into r into r. We are multiplying r with itself n times, which means we are doing r power n. Okay, r power n. When you multiply r with r n times, you will get a number, right? That is equal to x. We are taking it as x. So if r power n is equal to x, then we'll call this r as nth root of x. Okay, so if you can multiply r with the same r n times, then we can write r power n is equal to x, and that r is called nth root of x. Okay, and we can write it as root n means nth root of x. We can write it as root n x is equal to r, which means nth root of x we are getting as r. Okay, this symbol is there, right? Root n. This symbol is called radical. Okay, this symbol is called radical, and the n here is called index of the radical. This n is called index of the radical, and x is called radicand. So you can represent nth root of x in this notation. This notation is called radical notation, and the symbol root n, this symbol is called radical, and the n or positive integer is called index of the radical, and x is the radicand. Okay, so we'll see that now. Here the symbol which is read as nth root, this is called radical, and n is the index of the radical. Here we'll call it as power, right? Here it is power of r, but in this notation we'll call n as index of the radical. Okay, and x is called radicand, and this notation is called radical notation of nth root of x. Okay, and then we'll consider the radical notation nth root of x is equal to r. Okay, suppose if n is equal to 2, what we will get? R square is equal to x. Okay, then r is equal to square root of x. So we'll represent square root of x like this, right? If you want to represent square root of 4, how will you represent? Square root of 4, or simply we will represent root 4. Okay, example for this one is square root of 16. Simply we can write like this also, right? Simply we can write like this also, and square root of 16 is equal to 4, which means when you multiply 4 2 times, you will get 16. Okay, which is nothing but 4 square is equal to 16. This can be written as square root of 16 is equal to 4. Okay, this notation is called radical notation, and this is written as square root of 16 is 4. So if n is equal to 3, we'll get root 3 x is equal to r. Okay, that is cube root of x is equal to r. Okay, for example, cube root of 8 is equal to 2. which means what? If you multiply 2 3 times, that is 2 into 2 into 2, you will get 8, right? 2 2s are 4, 4 2s are 8. So this means when you multiply 2 3 times, you will get 8. This is nothing but 2 cube is equal to 8. This can be written as cube root of 8 is equal to 2. Okay, so this is cube root of 8 which is equal to 2. Fine. So this notation, the notation using this symbol, radical symbol, we are calling it as radical notation. Okay. Okay. Now tell me how many square roots are there for 4? Okay. You have to find out square root of 4. Which means you have to multiply a number twice to get 4. So when you multiply 2 times, you will get 4. Right? As well as when you multiply minus 2 times, you will get 4. So square root of 4 is plus 2 as well as minus 2. Okay, so root of 4 is both plus 2 and minus 2 are the square roots of 4. But it is incorrect to represent root 4 is equal to plus or minus 2. Okay. You can represent like this, but here it is incorrect to represent root 4 is equal to plus or minus 2. Why? Because it is accepted convention that this symbol, root of nth root of x, okay, this symbol is for positive nth root. So it is a convention, it is a rule that if you have written root n of x, this is positive nth root. So you have written here positive nth square root of 4. So positive square root of 4 is 2 only. Okay. And the symbol for negative nth root is minus root nth root of x. Okay. So symbol for positive nth root is root nth root of x, and the symbol for negative nth root is minus nth root of x. Okay. So therefore, root 4, positive square root of 4 is 2 and negative square root of 4, that is minus of root 4. Minus of root 4 is equal to minus 2. Okay, understood? Now, when n is odd, for any value of x, there is exactly one real nth root. Okay. Here in square root we have seen positive nth root and negative nth root, right? Because their n is even. But when n is odd, for any value of x, there is exactly one real nth root. Okay, for example, cube root of 8 is equal to 2, which means when you multiply 2 3 times, 2 to 2, you will get 8. Okay, suppose we have fifth root of minus 32. Okay, so when you multiply minus 2 5 times, minus 2 into minus 2. Okay, minus into minus plus 2 2s are 4. So here you got 4. Plus into minus, minus 4 2s are 8. So here you got minus 8. Minus into minus plus 8 2s are 16. So here you got plus 16. Plus into minus minus 16 2s are 32. So when you multiply minus 2 5 times, you will get minus 32. So fifth root of minus 32 is minus 2. Okay. So when we have n as odd, that is the index as odd, then any value of x, there will be exactly one real nth root. There will be no positive nth root, no negative nth root. When n is odd, when the index is odd, there will be only one real nth root. Okay. So now there is a thinking corner. Which one of the following is false? So here they have given 4 options. We have to tell which one among these 4 is false. See the first one. The square root of 9 is 3 or minus 3. This is correct, right? They didn't mention, they didn't use any symbol. They have simply told square root of 9 is 3 or minus 3. So when you multiply 3 2 times, you will get 9, as well as minus 3 2 times also you will get 9. So square root of 9 is 3 or minus 3. So this is true, right? and they have written root 9. Root 9. This symbol is positive nth root, right? So 3 into 3 is 9. This is positive square root of 9. So this is also true. First one is also true. Second one is also true. Now see the third one. This symbol means negative square root of 9. Square root of 9 is negative square root of 9 is minus 3 into minus 3. Right? Minus 3, sorry. So square root of 9 is 3 into 3. Okay. Then we have a minus symbol here. So here also if we put minus, you will get minus 3. So negative square root of minus 9 is minus 3. This is also true. The first 3 is true. Now see the fourth one. They have written square root of 9 is equal to plus or minus 3. So I have told you that it is convention if you represent this square root like this, which means positive square root of 9. Positive square root of 9 is equal to 3, not plus or minus 3. So fourth one is false. Okay. So till now we have seen how to represent radical notation. So you know, to represent nth root of a number, we use this symbol. This symbol is read as nth root and this is called radical. Okay, nth root of x. If you represent a number like this, then it is radical notation. Where here the symbol is a radical and n here is called index of the radical and the number here is called radicand. Okay, now we will see what is fractional notation. Okay, for that we'll consider the same radical notation. Okay, r is equal to nth root of x. This can also be written in some other form, that is using fraction. So nth root of x can also be represented as x to the power 1 by n. So this nth root of x can also written as x to the power 1 by n. Both are same meaning. Both have same meaning, only the representation is different. So you can write square root of x as x to the power 1 by 2. Okay. Cube root of x as x to the power 1 by 3. So nth root of x as x to the power 1 by n. Okay, so this notation is called fractional index. Here the index we are writing it as writing in fraction. Okay, so this is called fractional index notation. Okay, so if you represent nth root of a number like this notation, this is radical notation, and this also can be written in some other notation using fractional index, that is called fractional index notation. Okay, now we will see three different notation of a same number. Okay, so 2 to the power 6. First one we have taken 2 to the power 6. This is power notation. So in power we have represented 6, which means 6th root of 64 is 2. Okay, when you multiply 2 6 times, you will get 64. So this is called power notation. 2 power 6 is equal to 64. This can be expressed in radical notation like 6th root of 64 is equal to 2. 6th root of 64, which is equal to 2. Okay, this is the radical notation of this power notation. So how can we represent this radical notation in index, fractional index notation? So root 6 means 6th root can be written as 1 by 6 in the fractional index. Okay, so 2 is equal to 64 to the power 1 by 6, which is read as 2 is the 6th root of 64. Okay, now see the second one. 2 to the power 5 is equal to 32, which means when you multiply 2 with itself 5 times, you will get 32, which means 5th root of 32 is 2. Okay, this can be written in radical notation like this. 2 is equal to 5th root of 32. 5 root 32. Okay, here 32 is the radicand, 5 is the index of the radical, and this symbol is called radical. So this is the radical notation. We can represent the same thing in index notation like this. 32 power 1 by 5. Okay, and it is read as 2 is the 5th root of 32. Okay, now see the third one. 2 to the power 4 is equal to 16, which means what? When you multiply 2 with itself 4 times, that is 2 into 2 into 2 into 2, you will get 16. So fourth root of 16 is 2. Okay, that can be written as 2 is equal to fourth root of 16. This is the radical notation. Okay, and index notation, this is written as 6 to the power 1 by 4. Okay, here in index we have fraction. So this is fractional index notation, and it is read as 2 is the fourth power of 16. Now we come to the cube root of 2. So when you multiply 2 with itself 3 times, you will get 8. That is cube root of 8. So 2 is equal to cube root of 8. If you represent like this is radical notation. And if it is represented like this, 8 to the power 1 by 3, which is also same as cube root of 8. Okay, so 2 is the cube root of 8, meaning 2 is the third root of 8. Okay. Then square root of 4. 2 square is equal to 4. Okay. So this can be written in radical notation like this, square root of 4. So it is convention that if you didn't mention any radical here, that will be considered as square root. Okay. So square root of x you can represent like this, or simply root x, which means you are taking square root of that number. Okay, so in radical notation this is a square root of 4, and in index notation we will write 4 to the power 1 by 2, which is read as 2 is the square root of 4. Okay, so using these three different types of notation, we will try to solve the example problems. So before going to example problem, we have to know the meaning of x to the power m by n. X to the power m by n. So this is nothing but we are multiplying x with x m times, and we are taking nth root of x power m. So this is nothing but x power m by 1 by n. This is fractional notation, right? So this can be written as nth root of x power m, or m power of nth root of x, which is nth root of mth power of x, or mth power of nth root of x. So x to the power m by n means x power m, then we are taking nth root of x power m, or first we will take nth root of x, then we will power m. We will multiply this nth root of x m times. Okay, so x power m by n will be equal to x power m to the power 1 by n, or x power 1 by n to the power m, or it can be written as nth root of x power m, or nth root of x power m. Okay, so we have to understand this also. So when we have a number x power m by n, which is equal to mth power of nth root of x, or nth root of x power m. So both are equivalent. Okay. Now we will solve example problem. Express the following in the form 2 power n. So we have to express everything here in the form 2 power n. For that we have to factorize all the numbers. First we have 8. Factorize 8. 4. Again with 2 we will get 2. 2 into 2 into 2 is 8. Right. So 8 is equal to 2 into 2 into 2, which means 2 cube. Okay. So 8 can be written as 2 cube. Now take second one, 32. So factorize 32. When you do with 2, we will get 16. Then again with 2, you will get 8. Again with 2, we will get 4. 2, 2. Okay, so 32 is equal to 2 into 2 into 2 into 2 into 2. So 5 times. 1, 2, 3, 4, 5. Right? 5 times. So 32 is equal to 2 to the power 5. What they are asking, we have to write everything in the form 2 power n. Right? So 32 is equal to 2 power 5. Then see 1 by 4. 1 by 4. Which is equal to 1 by 2 into 2. Okay, which is nothing but 1 by 2 square. So here in denominator we have 1 by 2 square. We have to write everything in the form 2 to the power n. So we have to take this to the numerator. So when we are taking this to the numerator, we have to change the symbol of the power. We have 2 power 2 in the denominator. When you take that 2 to the numerator, we have to change the symbol of the power. So you will get 2 to the power minus 2. Okay. So see here, when you are taking this to the numerator, you will change the symbol. You have to change the symbol of the power. That is 2 to the power minus 2. So x to the power minus 3 means it is 1 by x to the power 3. Okay, so x to the power minus n is equal to 1 by x power n. Okay. Now see this one. This is square root of 2. Now we have 2 to the power n, right? So here you have to convert this into fractional index notation. So this is 2 to the power 1 by 2. Okay. Now see root 8. Okay. Root 8 is root 2 into root 2 into root 2. Okay. Root 2 into root 2 is root 4. Then root 4 into root 2 is root 8. Understood? But root 2 plus root 2 is 2 root 2, not root 4. Okay. When you are adding, you have to add like this. But when you are multiplying, root 2 into root 2 will be equal to 2. Okay. Then 2 into root 2. So you have root, this 2 is root 4 and root 2. Root 4 into root 2 is root 8. So this is root 2 cube. Right. We have to represent this in 2 power n. This root 2 can be written as 2 power 1 by 2 the whole cube. Okay. So now this is 2 to the power. This is square root of, this is cube of square root of 2, right? So this can be written as 3 by 2. 2 to the power 3 by 2. Fine. I will repeat this. Root 8 is equal to root 2 into root 2 into root 2. So we have got root 2 cube. And before we have seen what is meaning of x m by n, which is nth root of x to the power n, right? Nth root of x can be written as x power 1 by n to the power m, right? So this is nothing but this. So here we have 2 to the power 1 by 2, 3. So this will be equal to 2 to the power 3 by 2. Okay. Now we'll see the next example. Find the value of 81 to the power 5 by 4, which means 4th root of 81 to the power 5 or 81 to the power 5. Then we have to take 4th root. Okay, first we'll find out 4th root of 81. Okay, that will be easy. When you factorize 81, you will get, we can factorize with 3. 2 3s are 6, 7 3s are 21. Then again with 3. 9 3s are 27. 3, 3. So here we have 4. Okay. When you multiply 3 4 times, you will get 81. So 81 can be written as 3 to the power 4. We are taking 4th root of 81. So 4th root and 4th power will get cancelled. So we'll get 3. So this is 3 to the power 5, which means you have to multiply 3 5 times. 3 3s are 9, 9 3s are 27, then 27 into 9, you will get 243. So 3 3s are 9, 9 3s are 27, 27 into 3, 7 3s are 21, balance 2, 2 3s are 6, 8. Okay, 81. 81 into 3, 1 3 is 3, 8 3s are 24, 243. So 3 to the power 5 is 243. So 81 to the power 5 by 4 is 243. So what we have did to do this, first we have taken 4th root of 81. So when you multiply 3 4 times, you will get 81. So 81 can be written as 3 to the power 4. 4 power 4 and root 4 will get cancelled. So you will get 3 to the power 5. Okay, 3 to the power 5 means we have to multiply 3 5 times. So you will get 243. Okay, now see the second one, 64 to the power minus 2 by 3. So I have told you x to the power minus n is equal to 1 by x power n. Right. So we have to take 64 to the power minus 2 by 3 as 1 by 64 to the power 2 by 3. Okay, which is 1 by cube root of 64 square. Okay, what is cube root of 64? Factorize 64 with 2. Okay, 3 2s are 6, 2 2s are 4, 2, 16, again 2, 8, 2, 4, 2. So here we have cube root means 4 into 4 into 4. Okay, 4 4s are 16, 16 4s are 64. So 4 cube is 64. So this is 1 by cube root of 4 cube whole square. Okay, this power 3 and cube root will get cancelled. So you will get 1 by 4 square. 1 by 4 square is 1 by 4 into 4. Okay, 1 by 4 4s are 16. So you will get 1 by 16. Understood? So here 64 to the power minus 2 by 3 can be written as 1 by 64 to the power 2 by 3, which is nothing but squaring cube root of 64. When you find out cube root of 64, it is 4, because 4 into 4 into 4 is 64. Okay, so cube root of 64 is 4. Squaring cube root of 64, that is squaring 4. You will get 1 by 16. Okay, I hope you understood this. If you want to find out nth root of a number x, if you can write that as nth root of x like this. This is radical notation. This can also be written as x to the power 1 by n. This is called a fractional index notation. And if nth root of x is equal to r, we will write r power n is equal to x. This is power notation. Okay, so using this we have to solve these problems. And one more thing, x power m by n means nth root of x whole power m, or x power m then taking nth root. So both are equivalent. One more thing we have to see, x power minus n is equal to 1 by x power n. Or when we have 1 by x power n, to bring it to the numerator, what you will do? We will change the power of the sign of the power, that is x to the power minus n. Okay, so using this, solve the exercise problem, exercise 2.5. This is your assignment. So in first one, fourth one I will do. So we have to find out root of 125. Root of 125 means square root of 125. What is the question? We have to write the following in 5 power n. Okay, so they have given root of 125. Okay, now factorize 125. 5, 2 5s are 10, 5 5s are 25. Okay, then 5 5s are 25. We have to write root 125 in 5 power something, right? This is square root of 5 cube. 125 can be written as 5 into 5 into 5. So square root of 125 is equal to square root of 5 power 3, which is 5 power 3 to the power 1 by 2. This is fractional notation, fractional index notation. So this is equal to 5 3 by 2. Okay, so we have written here 5 to the power n. We have written in the form 5 to the power n. So I repeat, 1 root of 125. 125 is 5 cube. Okay, so we have root of 5 cube. Root of 5 cube is nothing but 5 cube to the power 1 by 2. So this is of the form x power n to the power 1 by n. Okay, this is equal to x to the power m by n, right? So this is 5 to the power 3 by 2. Okay, now see the second one. Write the following in the form 4 power n. So in this I will do third one. we have to write it in the form 4 power n, right? So we will do third one, 32. We have 32 and we have to write this 32 in the form 4 power n. Now factorize 32. With the 2 we do 16. So we have to do with 4, okay? When you do with 4, since we have to express in 4 power n, we have to do with 4. 8 4s are 32. 1 8 is 8, 2 8s are 16, 3 8s are 24, 4 8s are 32. Right? So when you do with 4, you will get 8. Again, when you do with 4, you will get 2. Okay, so this is 4 into 4 and this 2 can be written as root 4. We know that positive root of 4 is 2. So this is 4 square into root 4. Okay, 4 square into root 4 is 4 1 by 2. Right. So when you have a square into a, how will you do? This is a cube. We are adding the power. When you are multiplying the same radicand, we have to add the power. Right. So when you have a square into a, here you are adding the power. A 2 power 2 plus 1. A power 3. Right. So here also we have 4 square. Wait, I will erase everything other than these things. I will tell you one more time. Okay, so if we have a square into a, to do this, what you will do? You will keep the base same and you will add the power 2 plus 1. So a square into a is nothing but a cube. Right? Similar way we have to do here. Here the base is same. We are multiplying same base. So we have to add the power. So 4 into 2 plus 1 by 2. Okay. So 2 2s are 4. 4 plus 1 5. 5 by 2. 4 power 5 by 2. Okay. So 32 is equal to 4 to the power 5 by 2. Okay. So how will we get this thing? We have to express 32 in the form 4 by n. So we are going to factorize 32 using 4. Okay. Here 8 4s are 32. Again with 4 if you do, you will get 2. So you have 32 as 4 into 4 into 2. 4 into 4 can be written as 4 square and 2 can be written as square root of 4. Square root of 4 is 2. Okay. So square root of 4 can also be written as, that is, this square root of 4 can also be written as 4 to the power 1 by 2. So when we have multiplying the same base, we have to add the power. Okay, that is the rule. So 4, 2 plus 1 by 2. Now we have to add this 2 plus 1 by 2. Now take the LCM. LCM will be 2. So 2 plus 2, 2 into 2 is 4 plus 1 by 2 when you add these two things. So 5 by 2 you will get. So answer is 4 power 5 by 2. Okay. Now see third one. Find the value of. Here also I will do the fourth one, 64 by 125 minus 2 by 3. Okay. 64 by 125 to the power minus 2 by 3. This is nothing but 64 by 125. Here we have negative symbol. So to make this positive, we have to take this to denominator. So this is equal to 1 by 64 to the power 2 by 3. Okay. So now we'll take 64. Okay. 64. We'll factorize 64. 4. When you do with 4, 1 4 is 4. We'll be having 24. 6 4s are 24. Again with 4, 4. So this is 64 is 4 cube. Okay, now take 125. 5 cube is 125. Okay, 4 cube by 5 cube to the power 2 by 3. This is 1 by. Okay, 64 is 4 cube. 125 is 5 cube. Okay, so this is nothing but, this can be written as 1 by cube root of 4 by 5 cube to the power 4. Okay, this cube and cube root will get cancelled. So what you will get? You will get 1 by 4 by 5 square. Okay, 4 square is 16, by 5 square is 25. So you will get 1 by 16 by 25. So this will be 25 by 16. Okay, I will do it one more time. We have to do 64 by 125 to the power minus 2 by 3. Okay, so this can be written as 1 by 64 by 125 to the power 2 by 3. When you take this to denominator, this will become positive. So this is nothing but 1 by cube root of 64 by 125 whole square. Okay, 64 is 4 cube and 125 is 5 cube. This 4 cube by 5 cube can be written as 4 by 5 cube. So this will be equal to 1 by cube root of 4 by 5 cube whole square. So this cube and this cube root will get cancelled. So we will be having 1 by 4 by 5 square. Okay, when you square this means you have to multiply 4 by 5 2 times. 4 by 5 into 4 by 5. So what is 4 by 5 into 4 by 5? 4 4s are 16, 5 5s are 25. So you will get 16 by 25. 1 by 16 by 25, which is equal to 25 by 16. Okay, so answer for this is 25 by 16. Okay, now see fourth one. Fourth one, we have to use fractional index to write this thing. So this will be nothing but 5 to the power 1 by 2. This is 7 to the power 1 by 2. This is 49 to the power 1 by 3 into 5 to the power 5. So this is nothing but 49 to the power 5 by 3. Okay, now see the fourth one. 1 by cube root of 100 to the power 7. Okay, 1 by cube root of 100 to the power 7. So this is equal to 1 to the power 7 by cube root of 100 to the power 7. Okay, so this is equal to 1 by cube root of 100 to the power 7. Okay, so this is nothing but 100 power 3 by 7. 1 by 100 power 3 by 7 by 3. Wait, I will do it one more time here only. So we have to find out 1 by cube root of 100 to the power 7. So this is equal to 1 by cube root of 100 to the power 7. So this is nothing but 1 by 100 to the power 1 by 3 to the power 7. Okay, so this is equal to 1 by 100 to the power 7 by 3. Okay, then if you take this to upper side, you will get 100 to the power minus 7 by 3. That will be the fractional index notation. Okay, do you want me to repeat? I will repeat. So we have 1 by cube root of 100 to the power 7. Okay, so this is nothing but 1 by 100 to the power 1 by 3 power 7. Okay, 1 power 7 is 1 by 100 to the power 1 by 3 power 7. Okay, see, this is nothing but 1 by 100 to the power 7 by 3. We want to take this to upper side. So 100 to the power minus 7 by 3. So this is the fractional index notation. Okay, remaining things you have. So here in this exercise 2.5, I have done first one. I have done first one fourth problem, second one third problem, third one fourth problem, fourth one fourth problem, and then we have one more problem, fifth one. Find the fifth root of. So you have to find out root 5 of 32, root 5 of 243, and root 5 of this, root 5 of this one. Okay, so these sums are all homework for you. I will do fourth one, 1024 by 3125. We have to find out fifth root of this one. So first factorize 1024. Okay, when you do with the 2, 5 2s are 10, 1 2 is 2, 2 2s are 2, 2 2s are 4, 5 2s are 10, 6 2s are 12. With the 2, 1 2 is 2, 2 2s are 4, 8 2s are 16. 2. So this is, I think 4 power 5 is 1024. Okay, 4 into 4 into 4 into 4. We'll do 4 4s are 16. 16 16s are how much? 250 into 4. Okay, 16 16s are 6 6 are 36. Balance 3. 1 6 is 6. 96. So you will get 256. 256 into 4. 6 4s are 24. Balance 2. 5 4s are 20. 22. 2 2 4s are 8. 10. So 4 power 5 is 1024. So 1024 is equal to 4 to the power 5. Okay. Now 3125. 5 to the power 5 is 3125. Okay. 5 5s are 25. 25 into 25 is so we have to find out 5 to the power 5, right? 5 into 5 into 5 into 5 into 5. So this is 25, 25. 25 into 25. 5 5s are 25, balance 2, 2 5s are 10, 12. 2 5s are 10, balance 1, 2 2s are 4, 5. So this is 625. Now 625 into 5. 5 5s are 25, balance 2, 2 5s are 10, 12, balance 1, 6 5s are 30, 35, 31. Okay, so 5 to the power 5 is 3125. So we got 3125 is equal to 5 to the power 5. So this can be written as 4 to the power 5 by 5 to the power 5. We have to find out fifth root of this. Okay, so this can be written as fifth root of 4 by 5 to the power 5. This power 5 and fifth root will get cancelled. So this will be equal to 4 by 5. Okay, fourth one is equal to 4 by 5. This is how we have to find out these things. All other things except what I have done will be very easy. So you have to do exercise 2.5 as your assignment. Okay, thank you. We'll meet in next video.